quite eye-opening. Mind-boggling is actually what it looks like to me.
These AIs are going to need access to money at some point.
128 gigatransfer per second optical link using linear optical connectors, off-the-shelf connectors with no retiming needed. So that's a nice breakthrough.
Execute on things that people actually want and the competition's inability to execute. So you combine those three things and you do it for 20 years, you get what we have right now.
Funding some SMRs, some small modular reactors.
They're all funding SMRs as well.
Welcome to the Orion X Download Podcast. Join Shaheen Khan, the Orion X analysts, and special guests as they discuss and simplify the big ideas in technology that are changing the world. Thank you for being with us.
Hi everybody, welcome back to the Orion X Analyst Roundtable, or as we fondly refer to as ART. With me as before is Adrian Cockcroft, Chris Krull, Stephen Perno. How are you, gentlemen?
Thank you.
Well,
Yep, fine.
All right, excellent. So we have a packed agenda here. So without further ado, let's start just randomly with Internet of Things, IoT. That's a topic that was pretty hot a couple of years ago, and it's kind of morphed into edge, and it's going to get its renaissance when it becomes ingrained like it was supposed to be. There were a whole bunch of challenges in implementing it. So this is all like a long segue into a project that Adrian has picked up over the past couple of months and has morphed into a very, very nice case study of AI coding.
Actually, it's not a couple of months, it's like a few days.
Oh,
We're moving at the speed of AI here. We're not taking months to do things.
so dog years and AI years are kind of...
Yeah. I'm finishing up a blog post which will have posted by the time this podcast comes out. And the title I have is Vibe Coding is So Last Month. My first agent swarm experience with Claude Flow. And so I've been vibe coding, building things, what I want using Cursor. And then recently I moved last week to using Claude Code, which is more command line based, a little bit more flexible. And there you have a single threaded AI engine, which is writing code for you and doing what you want it to do. But I've been reading stories on LinkedIn posted by Reuven Cohen, who's someone I've known for a long time, has always been at the leading edge of technology. And he's been talking about this system he's built, which is an agent swarm system with a whole lot of framework built around it to get it to the swarm of agents to be directed and controlled and sort of corralled to solve a problem. And it looked interesting enough, and I just want to try that. So then I had to, okay, now I need a problem. I need to build something from scratch, really, with this. I want to start with a clean sheet, give it a rough idea of what I want, and get it to build it. And something that's been bugging me for years is the idea that all the different systems around my house that don't talk to each other and are too complicated to configure, and it's just a big mess, right? And that's the way every IoT system becomes as you keep adding things. And I think there's like the other way of building IoT is everything is pre-built from scratch from one vendor. Like you get a fresh built house and everything is from one vendor and it all works together and it's pre-built and everything's fine, right? And then, but over time you can adding new things which didn't come from that vendor. So you end up in this mess, whatever you start. And I tied that to some thoughts I had. I wrote a blog post quite a few years ago when I was reading about consciousness as a thing. And I started thinking about whether consciousness was really another phrase for another way of looking at observability. So a system is observable if you can see what state it's in. That's the principle of observability. And the way that you tell a human what state a human is in, or what state you're in, is by their consciousness, by being able to talk to somebody that they can consciously express what state they're in. So in some sense, and of course the other thing about consciousness is when things are unconscious, you can't talk to them, right? So if consciousness has meaning as a word, then unconscious, it must be the thing that goes away when you become unconscious, right? That's sort of one way of thinking about consciousness. And then other people conflate consciousness with intelligence and go all carried away. But for me, it's what goes away when you're unconscious. So if a system that's not observable, it's effectively unconscious. Anyway, I wrote this sort of very philosophical blog post a while ago. I decided I want my house to be conscious and I want to be able to talk. My house to just be tracking all of the IoT things and making sense of it So I had this general idea that things should be more observable by giving them a conscious personality that you can interact with the same way as you'd find out how somebody is by talking to them. You should be able to talk to a system. And then the kind of systems that I could do that for and build myself right here is my house. So I have all the IoT systems in my house. I have a rather complicated bunch of different things that control different aspects of the house. I have different interfaces I need to go to. And it's complicated to consider building something that integrates a house. So if you go to, there are consultants that do integrated house projects. You hire them, you pay them probably a few $100s an hour for a pile of time, and they configure a system that integrates your house. And a lot of it is like tinkering around, doing bits of development. So what I thought was I'd actually just like to have a system that does that. But what the LLM lets you do is, instead of having a consultant there configuring all the different bits around the house, I then have an LLM do it. So what I want to do is build the framework that is the base system. And then conceptually, rather than having a consultant coming in, I'm going to have, Claude or a Claude code system, a bunch of agents, which if the system needs to be configured or changed or developed or made to work or debugged or updated, I don't have to, call up the contractor and wait a month for them to turn up and pay them a lot of money. It's there immediately. I just fire up my Claude account, spend a few dollars on tokens, and it'll reprocess whatever it needs to do to fix it. So that's conceptually it. And from an abstract sort of point of view, I think this is a new class of application where the LLM is delivered as part of the delivery of the thing. And it's a little bit more, it's similar to some ERP systems like SAP, for example, where the SAP consultant and the configuration is most of the cost, because every company is different and their ERP is different. And if you're trying to do a climate analysis, a carbon footprint analysis in a company, the data, that it's a very, very consultant intensive thing to go do. So maybe there's a class of application now where the LLM agents can take over what those consultants were doing to interface to all of the specific systems that a house has, and maybe develop a few new ones that it hasn't seen before, and then contribute that back into some shared repo where it gradually accumulates all the things it needs to talk to. So that was the idea. It's a bit grandiose. And going back to what I was saying earlier, so Reuven Cohen's been using these agent swarms to go solve for problems. And at some point he said he'd be happy to get on a call for me with a half an hour or so to just chat about it and get me started. So I got Claude Code installed, played with it long enough to figure out what I was doing, and then Reuven got me started with what he's built, which is called Claude Flow. And this is so basically each agent's got a different personality. One is the architect, one is the DevOps for installation, one is the QA, and then there's sort of different specialist developers, maybe a front-end developer, a back-end developer. And each agent becomes, you don't have to tell it to do this. You say, just start 5 agents to solve this problem. And it figures out a likely set of 5 or however many you want agents to go solve it. And then they cooperate to build the thing. And over a day and a half, about 150,000 lines of code were written. It came up and ran. It's not like a usable finished system by any means, mostly because I didn't spend enough time thinking about the user interface and how I wanted it to work. So the next thing I'm going to do is go back and replan this is what I'd like it to be. These are the user flows, spend a lot more time thinking about how it should be used, and then just tell it, just redevelop it against that plan and it'll build it. But I have a database layer that's up and running with the schema, the dynamic schema. There's a whole bunch of, the code runs. It's just I didn't really specify what I wanted well enough for it to be the finished system as I'd like it to be. So quite eye-opening, mind-boggling is actually what it looks like to me. I don't know.
I believe the word you used was, it's nuts.
It's nuts that you can do this. Yeah. And it was like, is Reuven, because people say, that Reuven thing, he's just doing random stuff. No, it does seem to be working. He's building things himself using this. So he's accelerating into the future by being able to use this tool to build the next tool. Like the Claude Flow only existed a week before I started using it, and he had 50,000 downloads of it. There's another thing in here that he built called Safler, a self-aware feedback loop algorithm, which is basically the little It's a continuous learning kind of system in some sense. So it's a feedback loop. He built that. He's using that for some other tools. He built that a few weeks ago. Yeah, I need that. So that's sitting in the core of this. So the house will gradually learn about what's going on around it. That's the idea. Anyway, it's a huge, ambitious project. It's cost me, I'm on $100 a month plan right now. So that's the cost that's gone into it. It's ludicrous that this could be built so quickly.
Well, several things that come to mind. One is just immediately, there are a lot of people who legitimately don't believe AI can do what it purports to do. But there's also a lot of stuff that AI can in fact do. So I think if you're out there, you want to have a realistic view of what it can and cannot do. You don't want to underestimate what it can do, and you don't want to overestimate what it cannot do. And that's a problem in our society. Examples like yours are incredibly eye-opening because this aspect of what you're experiencing couldn't be any more real. So can you guys talk about what you see and what is the right perspective to have?
One thing I think is that this sort of, if you're technical enough to remember vaguely how code is built, a lot of people have developer backgrounds but now are doing something else, or they've coded at some point. There's some tooling that you need to figure out how to use. Most of my struggles have been trying to understand how to use things like GitHub.
Right.
Like, I don't really know how to use GitHub properly. It's complicated. I use the AI to do things to GitHub rather than remembering the commands to how to do it. But mostly it's the tooling is the things I've been struggling with, not the AI building the application. So once you've got your head around tooling, or the tooling gets a bit easier to use because it's all still very fresh. I think this, that old phrase, democratizing access to stuff, right? I think anybody that's got an idea, you could just get it to build that idea. And that means that there's going to be a lot more stuff out there that we'll be able to iterate on ideas much more quickly. So I think that's the interesting thing. This is an idea I've had for a long time. I've never been able to build it myself or to persuade anyone else to build it for me. So now I just make it because I don't have to wait. Right? That's the freeing nature of this.
I think back to the beginning of browsers and Netscape and information all of a sudden proliferating on the internet, right? And my thought at the time was it'd be really useful to have an editor or editors to help me sort through what's important, what's not. And fast forward 30, 40 years, whatever it is. And here we are. If we're going to have a proliferation of apps or tools or ideas, once again, we're in this position of how do we sift through this enormous proliferation. And the other thing I think about, there's a lot of talk over the last couple of years about AI replacing people and so on and so forth. And sure, it's going to replace some of the functions that we do, but every time an innovative wave of technology appears, we humans just move up the stack, right? We just
hopefully,
hopefully. Well, but at the end of the day, how many of us know programmers? Whose day job is coding? This has become a very useful tool, but the person doesn't go away. It's just become way more productive and so on and so forth. So,
well, there is kind of the Jevons paradox. Adrian, you mentioned it in one of the LinkedIn discussion that I was following, that now that you made it so easy, you're going to attract many more quote unquote developers, even though these new batch of developers aren't developing the same thing or the same way as the previous batch. So the label continues. So there is that aspect.
I think the pushback that a lot of people say, well, yeah, but it builds something that's buggy, and then you've got to debug it. You have to supervise it. What the agent swarm does, it is debugging it. It's doing test-driven development. It built tests first, and then it coded to the tests, right? It's got the oversight built. And when I'm coding with a group of agents, it's like a team of developers with different specializations. It's better than any individual one. So this is the big aha moment for me. It just works better. Every time I do something now, I could just ask Claude to do it, but actually I ask Claude Flow to create a swarm to do it, because I know that it's going to check on itself and you get a better answer out of it. So the supervision is happening autonomously. I think that is the next step that most people haven't got their heads around. There's this other thing that there's an asymmetry here. It's like I can sort of understand French because I did high school French. I can't speak French. I can't think of French words. I can sort of read Python, but I can't write Python, right? So it's easier to build an agent that can understand something than produce something, right? So you can build guardrail agents that actually work really well, But the thing that's producing is actually the hard part. But the guardrail acts as a constraint on it. And the constraints actually work better than the thing that's building in the middle, right? So then you keep iterating in the middle until it meets whatever the guardrail is, whether that's a test-driven development or like trying to get some objectionable content filter, right? When you're chatting to LLMs, they have all these sort of filters that try to say, no, you're not allowed to talk about that. It's easier to, it's like the old thing of like, I don't have a definition for pornography, but I recognize it when I see it, some judge said years ago. That's the kind of model we can get. So you can build these guardrail agents and then have effectively a safe sandbox where a lot of iteration can happen in the middle.
Yeah. So I think if you're out there and you're skeptical, you really want to catch up with what is happening for real and how some of the problems that you thought were insoluble, in fact, have been solved. And on the other side, if you think it can do it all, you may want to temper expectations and find out exactly what it cannot do that remains to be done. But the point is that this trend is coming in a big way, and it really, really requires evidence-based critical thinking, not ruling anything out, but also not ruling anything in. So
it's basically, the problem is finding the sweet spot for the tool, right? We all have tools. They have a sweet spot. They don't do some things well. They do other things well. But the problem is the sweet spot is moving really fast. So
right.
you have to get your head inside and play with enough to realize, okay, well, it still doesn't do this, but it does this super well. And
like you said, wait a month and it can do it. Yeah.
Yeah, wait a month.
Yeah.
If you think what I'm doing doesn't work, then wait a month, it'll do it.
Right.
We're kind of at that stage.
So I want to cover, I spent a couple of years on IoT a few years ago, and I want to share what I remember to be the challenges of IoT, because you have a thing and it needs to communicate, and there's a mobile app and there's a cloud, and we have to bring all of these. So my recollection was what you said, that building it from scratch is way better than retrofitting it. It's harder to make a device that isn't smart and turn it into a connected smart thing. The sensors aren't there, the actuators aren't there, some of those things aren't there. So that's one thing. The second thing is that it's easy to do one singular device. It's way harder to do 100,000. When you get to millions, it becomes way harder, because now you're also putting load across all of those things, and response times get changed, and connectivity, this, that, and the other. So scale is a problem. The next one is geography. It's okay to do it in one country. It's harder to do it across multiple countries. Now you have to worry about connectivity, this, that, and the other, what cloud zone to use, what sort of tax implications. And then the next thing was multiple devices. It's okay to do one category of device. It's okay to do like light bulbs or washing machines. It's harder to do a dozen different devices. And that leads to this notion of a super application, that can I have just one app on my phone that manages all of my devices? And the answer is like typically no, because every device brings its own app that you need to download. And like you were saying in our pre-call, Adrian, companies kind of want to maintain control, albeit there are some people like Home Depot that have one app for all the branded devices under their brand. So do you guys want to add to that, or is that a good list?
I have like HomeKit stuff. I have Amazon Alexa stuff. There's a open source thing called Home Assistant, which has interfaces to thousands of devices. That's what I'm trying to leverage with this. My tool, I said, go look at Home Assistant. And it went and it read up and found out about it. It says there are drivers for everything. I can use them, right? There's no official driver for my particular Mitsubishi air conditioning system, but Home Assistant has one, and somebody's reverse engineered the protocol. There's a driver for it. So that's kind of the model. But yeah, this is what I want to build, and I may at some point tell this agent swarm to just build me an iOS app that talks to this system. And I want it to be conversational. Like if I have a new device, I go buy a new thing for the house, I want to be able to chat to the device and say, I've got this new thing, and it asks me all the questions. Then it goes and builds the code in the background. The LLM builds the code, implements it, tests it, and then updates the system. And then I'm running with my new thing. But it makes, I'm not trying to configure a fixed structure, go find a device. Should be a conversation. That way somebody that's non-technical can build and can manage and operate the house and extend it. And that's that way it can explain what it's doing in sort of normal terms. So you kind of have a house automation consultant built in as part of the tool. Anyway, it may never work. I may have bitten off much more than I can chew, or it might be working next week. I don't know. We'll find out. But
Right on.
so just I'm sharing everything I've got on GitHub. If you find Adrian CO, which is my GitHub account, it's all under something called consciousness. So that's the generic name for the thing.
Excellent.
And there's a lot of code there, which will be in some random state depending on how much time I spend on this by the time you listen to this podcast.
Right
It's
on.
moving super fast.
Okay, I kind of want to move now I want to have a segue into crypto, if you don't mind, and then we'll come back and do the other topics. So some years ago, we had this notion of, IoT was a thing. So we had bank of things on the assumption that these things are going to want their own bank accounts and they're going to want to transact with each other. And some of these transactions were going to be super micro transactions, and the transaction cost could not be higher than that, etc. So that led us into the crypto world. And it seemed to be like a pretty interesting application for cryptocurrencies to be imposed on or integrated with IoT. But anyway, that's my segue into cryptocurrency. And Steve, you published your semi-annual report. Let's talk a little bit about that.
Yeah, I remember those conversations that we had, and I think we were a little bit ahead of
Always.
ourselves or reality with those. But I think it's also starting to get closer to manifestation because of AI and the developments with, generative AI. These AIs are going to need access to money at some point. They're going to need to be able to purchase data, for example, in order to run their models with data that they feel that they need. And in order to purchase that data, they're going to need to have monetary technology. And since they don't have credit cards and they don't have bank accounts, the most natural thing will be to have a digital asset. So that's a little bit of a segue into this report, which we do twice a year. And we've been doing now for 6.5 years. The first one was at the end of 2018. And we look at this as a manifestation of supercomputing. And so we produce the reports in conjunction with the two large supercomputing conferences that are held in November in the US and in the June timeframe in Europe. And so we've just released, right after the close of ISC, we released this information early last week for this 14th report. And I just want to give you a little contrast between the first one in November of 2018 and now 6.5 years later, how things have changed. First of all, this is about high performance computing and supercomputing in order to create or mint these cryptocurrencies. And so that means you need really a proof of work consensus algorithm, because that's the only kind that has a lot of computational work going into it. And that's, people refer to as hashing. You have some problem that you have to solve a cryptographic hash function. You have to make a lot of guesses. It's a winner take all lottery. And the first, many mining rigs around the world to solve for that particular block gets a reward and it mints new coins. So over the whole period, we've had as many as half a dozen that appeared on the list simultaneously. Bitcoin always, but many times Ethereum had been on the list, and Litecoin and Bitcoin Cash, if we go back all the way to the end of 2018. But as time has gone on, the dominance has moved more and more to Bitcoin. So in the latest report, we have just two. Bitcoin and Dogecoin is replaced Ethereum as number two because Ethereum completely dropped. 2.5 years ago, they completely dropped proof of work and went purely to proof of stake. So we've seen consolidation. The number of different cryptocurrencies has grown from 2,000 then to really tens of thousands, of which about 10,000 are active, plus millions of meme coins by now. And the vast majority are worth little. There are only several dozen that are worth more than $1 billion, shall we say, for market cap. The Bitcoin market capitalization has increased by a factor of 20 and is now over $2 trillion, which you can easily calculate because about 20 million out of the ultimate 21 million have been minted by now. And the price is a little over 100,000 as we speak. And that price has increased by a factor of 17 since we did our first report. The annual production value for Bitcoin has grown by a factor of 4.5. It's gone from 4 billion to 18 billion. And the reason why it hasn't scaled as much is because built into the algorithm are these halvings. So every 4 years, the reward gets cut in half. And that's the deliberate method that's used to keep the ultimate supply finite and to have it taper off to this ultimate 21 million that we're pretty rapidly approaching. The Bitcoin hash rate has gone up by a factor of 16, so very similar to what the price has done over the past 6+ years. And as an aside, there was a little bump in the past week. Right now, the hash rate is 1,000 exahashes a second. And in a moment, I'll compare that to the top 500 in the supercomputing world. You could also call that a zettahash, but typically we've been in this hundreds of exahashes. Each one is a billion hashes per second. And last week it fell by 1/3. And people speculated, well, is this because Iran was mining a lot of Bitcoin under the mountains there somewhere? They got disrupted. Their communication networks got disrupted. Really, it turns out probably not to have been the case. The best estimate is about 3 or 4% of the Bitcoin mining may take place in Iran, but 10 times as much as that takes place in the US. Just the top, as we show in our report, just the top dozen publicly traded mining companies that are primarily based in North America and are concentrated in West Texas, is the highest concentration. They alone produce about 25% of the global hash rate. And it's estimated that more than 1/3 of the hash rate is in the US and Canada. So probably what happened was hot weather in Texas, even in East Texas, right? Because they're getting all their electricity from West Texas. And these mining facilities have agreements with the EPCOT provider that when they reach peak demand and everybody's turning on their air conditioning, when they come home at 5 o'clock in the afternoon and the load demand is very high, then they ask the Bitcoin miners to shut in, and they actually have contractual relationships that help them get lower electricity prices for the off-peak times. What else? The overall cap has gone up by about 15 times if you include the Dogecoin. There's about 18 billion of annual production in the Bitcoin, and there's another billion that's produced in the number 2, the Dogecoin. Now, just a quick comparison with the top 500 list. I mentioned this 900 exahashes a second, which is what we put in the report. I just checked, it's now 1,000 right now. So we've entered the zettahash range. If you take collectively all of the floppage, the peak flop rate on the top 500 list, I just did a quick scan. It's something like 15 exaflops. And here we've got 900 exahashes. Now, those are single 64-bit floating point operations, but a hash is many operations. They're low level, they're bitwise, they're bit logicals and rotates and so forth, at bit adds, but there are over 1,000 of those in every single hash, which is a dual shot 256 hash. The hashing power has increased by about 40% over the past year. And if you estimate how many systems around the world, it's probably something like 5 million servers. If you took the fastest generation, you'd need, 2.5 million. ASIC based, so these are very special purpose hardware. But collectively, they have hundreds of millions of cores because they're, heavily multi-threaded and multi-core. And that's comparable as well to the top 500 list. The amount of power consumption is of order 21 gigawatts. And so, that's a couple dozen nuclear reactors worth distributed around the globe. The investment in capital equipment is something of order 20 billion. The lifetime is pretty short because the difficulty is increasing very rapidly, faster than the 6th power of Bitcoin's age. Over long periods of time, the 9th power. So it may have slowed a bit, but it's very rapid increase, much faster than Moore's law. So it's what we call a Red Queen race. You have to run faster and faster just to keep in place. It's a brutally competitive business. And for that very reason, most of these publicly traded miners have now added to their portfolio hosting HPC and AI workloads. So they need different hardware in their racks. They put in GPU-based hardware rather than ASICs, but a lot of the infrastructure and the know-how of running an efficient operation can carry over, and it provides them some revenue to smooth things out.
Speaking of being several years ahead, we've been saying for a long time that there's emerging synergy between Bitcoin mining and HPC, and therefore by association AI. Some of us were on a call with a liquid cooling company that had its footing in crypto, but now being pulled into data center adjacent markets. You look at the technology that is used for these crypto mining chips, it's really every bit as high end as the latest GPUs and CPUs.
It's quite close. They're in 5 nanometer right now, and they get their chips from TMSC and from Samsung.
Exactly. And their volumes are pretty non-trivial too. So it is all an area of technology that is eligible, kind of behooves us to follow. And there's a lot that's going on that is pretty real. You mentioned top 500. I want to quickly talk a little about the top 500 list that was announced a few weeks ago. They also do a semi-annual, of course, as you mentioned, and it was at the International Supercomputing Conference, ISC, that you mentioned. So net, it's not supposed to be an exhaustive list. It's not supposed to be the only computers that are high performance. It's whoever wants to play. But they've been doing it for 32 years now, 32 and a half years. And this was the 65th edition of the list. So there is a lot of historical data that is highly valuable in terms of architecture, in terms of approach to getting performance, in terms of, for example, you could totally see the emergence of RISC and then the emergence of parallel systems and the emergence of GPUs. Those are all kind of visible. And to kind of put a summary on it, the top 3 systems are from the US. They're from the Department of Energy, Capitan, Frontier, and Aurora. There are multiple benchmarks that they run in 64 bits. One that is really pretty well behaved, and it's like dense matrix solvers. One that is much, much harder to do, and that's the conjugate gradient benchmark that almost sets a lower bound of performance. And there's one new system in the top 10 that's from University of Jülich in Germany that is destined to be the first exascale site within Germany. It's an Evidence system, which is a French company that is kind of becoming the European champion for supercomputers. And Europe is kind of looking to be more and more visible because they're spending a lot of money on science, on computing. They're peanut buttering the systems across Europe. So they have more hefty systems, but few world beating yet. At this point, still more than half of the systems on the top 500 do not have a GPU. So A, CPUs can still do a lot of heavy lifting. B, there's a lot more turf for GPUs to conquer. AMD has been gaining on Intel, but Intel's still leading. So that's another kind of interesting observation of the market. And then more than half of the systems are using InfiniBand at this point, but that's like 53% to like 40% or something. Steve, you want to say?
These ASICs are incredibly efficient and highly optimized for the particular problem for Bitcoin mining. We've certainly seen some specialized chips in the AI space, but right now, GPUs are still dominating. Are we going to see a shift towards very highly customized tensor designs, etc.? What do you think?
So my take is that all the AI chip vendors will ship everything they can build. The demand is just high enough, and NVIDIA continues to be short supplied. But NVIDIA has a lock on capacity. Last year, they shipped something like 20 times more than the next person, the next vendor. And not only have they locked up capacity at TSMC for chip manufacturing and then packaging, they have gone down the supply chain towards systems. So they're also like reserving capacity with server manufacturing, like the ODMs manufacturers as well. So regardless of how excellent your GPU is, if you can't ship, you can't ship. And NVIDIA can. Now, it also happens to be the case that their GPUs lead in performance, in ecosystem. All the drivers are there, or the systems are there, or the software is there. You don't have to really think about whether or not something is available. So it's an easy choice. Now, you do pay a little bit more for that because they are the market leader. And if you are brave, if you know exactly what it is that you need, if you do know that you only need this piece of software and not that, you could find lower cost options, potentially higher performance options for the one thing that you need to do. Now, all the new players are moving towards inference because that's an area where you could optimize for the particular application. For training, I believe it's pretty much locked up by NVIDIA and AMD at this point. AMD is coming fast and furious too, but they are really a distant second. Adrian, Chris, you guys want to chime in?
I think what I've seen from NVIDIA is that their preferred delivery isn't a chip, it's an NVL72 rack. They're shipping out entire racks as a bundle, everything tested and working and integrated, and they're shipping them to people like CoreWeave in large volume. I think CoreWeave recently did a benchmark with thousands of GPUs in it, or tens of thousands of GPUs, something in that range. So they had lots of racks set up and running to show they have it. And they're also supplying Azure and Google Cloud with capacity through CoreWeave. So that's kind of moving up the stack effectively for NVIDIA. They're delivering these boxes as their unit of capacity, and then the software will start building around these boxes, right? That it starts to become easier to build the layered software and the applications when you know that that is your building brick at a high level. So I think that's the interesting change from being a chip vendor to being a systems vendor that they've navigated. And like you said, they've locked up the capacity for doing that. And then anyone that can't figure out how to accept an NVL72 into their data center is struggling, and that AWS is struggling right now because this doesn't conform to their architecture. And if you're a enterprise and you want to drop some of these things in your environment, you've got big problems. Meanwhile, the biggest data centers in the world, I think, are the Facebook ones now, or the OpenAI ones right now. I saw something saying it was like the world's largest building is an OpenAI data center somewhere.
That's right. Now, speaking of the cloud and big hyperscalers, they are all building their own AI chips. So AWS, Microsoft, Google, of course, is already in like the 6th generation of their TPU. And Facebook, Meta, they just taped out their AI chip. So all these big guys will have their own, and they will have enough volume in-house to warrant it. So that kind of further complicates the market segment. But really, the big pro tip out of all of this is build stuff that people want to buy. Because
AWS specifically targeted a TSMC process that NVIDIA wasn't mainlining on, so that they would have effectively unconstrained volume without competing with NVIDIA. So I think that's another good strategy to go to one of the so they end up with the GPU, the Trainium and Inferentia GPUs are roughly half the performance of the NVIDIA because they're in a lower technology, but they aren't supply constrained and they can have their own cost model on it. So I think that's sort of what people are having to do. But like I said, NVIDIA's locked up all the best stuff and they've got enough money and capacity to do it. So they've got a fairly durable advantage at this point.
Yeah, it increases your volume too.
Obviously, a background in marketing to build stuff that people want to buy, but it does make me think back to Steve's question a moment ago. Is okay, so the Bitcoin miners figure out an ASIC that works for them, and there's got to be a balance. And I think about there's the high end of the marketplace, NVIDIA wins, but you would think that perhaps as AI makes it easier to design these specialized ASICs for particular use cases, maybe it makes sense to develop put things in hardware that we might not have otherwise in the past. But where's the volume? Where's the bottleneck in manufacturing? Those kinds of things might cause that to pause. But again, you get these guys that are big enough to build their own device.
I think for cloud usage, for backend servers, that kind of is the case. But NVIDIA is also expanding into robotics, into desktop, into their kind of Mac Mini lookalike, DGX Spark. So they are pretty comprehensive. And everything that they do in terms of market position is root caused to their ability to execute on things that people actually want, and the competition's inability to execute. So you combine those three things and you do it for 20 years, you get what we have right now.
Yeah. And as you say, if you're going to win against these folks, you have to do something better and faster.
Yeah. You have to do it well, and they have to fail. And that has been the case since 2005. Right?
Yeah. I'd forgotten about the EGX Spark sort of desktop. That's probably a good target for my consciousness system, so that you can actually have the inference and the LLM effectively running locally on it or within your house.
Yeah. It's
So I
running
was
what they
thinking of like
call
a Mac
the
Mini kind of level of stuff, but yeah, that's probably the right target. And then, what I deliver normally would call out to Claude or OpenAI or something to provide it with the extra intelligence over what it would need locally.
right on. It's running what they call a Grace Blackwell 10. So it's a trimmed version of their Grace Blackwell. It's a little bit more expensive than a Mac Mini, probably like 3-4x, but it's a pretty sweet looking system, and it
I might
looks
have
like
to
a
get one.
golden brick.
Maybe I'm building an excuse to buy one here. Okay.
I had to buy one for my wife, and it was only because it looked pretty and had flashing lights. She's got 3 monitors, and I have one. And
It's
Oh,
beautiful.
wow.
So
Yeah.
that's really the purpose of then is a pre-sales for NVIDIA. All right. So the other thing that came up recently was the specifications for PCIe 7, also Ultra Ethernet Alliance. That sort of segues into Ultra Accelerator Link and CXL. Chris, you were tracking that. Do you want to lead that discussion?
Yeah, and just a couple of highlights. I mean, every time PCIe revs the PCIe spec, they double the bandwidth. So we're at 128 gigatransfers per second per lane with PCIe 7. We're a ways away from having product in the marketplace, and that'll be entering at the data center level, of course, because the processors are more powerful. You've got to wait for chipsets to be there to work with that. One of the things that I've noticed is that they're talking about optical being at the front and center of their thought process in these designs as opposed to an afterthought. So in that spirit, Cadence demoed 128 gigatransfer per second optical link using linear optical connectors, off-the-shelf connectors with no retiming needed. So that's a nice breakthrough. And they're maintaining a consistent pre-FEC bit error rate of 10 to the minus 8, whereas the spec is for 10 to the minus 6. So that bodes well for integrating more optical into the PCIe world. So there was that. And I'll just segue to the UEC, the Ultra Ethernet Consortium, and maybe we can talk about the implications of both of these in a second. So the Ultra Ethernet Consortium now has grown to over 100 members, which is clearly people are paying attention. Yeah. I haven't signed up yet, but maybe next week. But they released 1.0 of their spec this month, and they've optimized a few things, what they're calling a more modern RDMA, or remote direct memory access. So they're looking to scale to upwards of 100,000 nodes, which is pretty remarkable. InfiniBand has kind of claimed that high-end space, but they're in the tens of thousands of nodes. Maybe their spec might call for 100K, but Ultra Ethernet is wanting to go beyond that. And we have Arista out there with some product that they say is Ultra Ethernet capable, Ultra Ethernet ready. I'm sure there's other vendors out there as well. So, but they've, like I said, they've optimized some of their communication protocol to maintain low latency and span multiples of boxes, clearly.
I think the old formula continues to be valid, that every networking technology somewhere in the data center will create a market all around it. Ultralink for GPUs to PCIe 7 to CXL that also provides memory things within a rack, let's say, and then Ultra Ethernet across the data center. Those kind of claim their zones.
I spent some time in the SSD at the client level, at the PC level in that world. So when I see these types of announcements, my brain immediately goes to, when will my MacBook Pro have a PCIe 7 SSD in it? That's clearly a ways off. But the PC manufacturers are delivering PCIe 5 now. But as we get these more powerful AI-focused workstations, bandwidth is going to be important if they can reach out to.
It kind of takes 3 to 5 years before they permeate everywhere.
Yeah.
PCIe 6 is around the corner, and 7 probably by 2007 or something, you're going to see systems have it.
Yeah.
Fujitsu announced that they've got clearance to proceed with their next generation supercomputer, Fugaku.next, based on a new Fujitsu chip that has CXL on board and a bunch of other things.
I think that's CXL 3.0, right? So
that's correct.
Is PCI 6 based. So the big transition in PCI was when they went to the sort of packet-based thing called a FLIT. So there's a packet that gets moved around rather than it being much more like a cache line level of transfer. And that happened in 5, which is the first version of CXL, which is shipping now. CXL 1.1 is based on PCI 5. And then you have to wait for the CPUs to support 6. So some of the upcoming CPUs
Right.
are going to have 6.0 in them. And that's where the double data rate PAM4 encoding comes in on PCI 6. And then 7 doubles it again. I forget exactly how they doubled it, but it's sort of, those are the different things. So we've got kind of the standard that's out there, the chips that are the one that's good enough that they're actually designing chips and talking about chip specs for, and then the one that's actually shipping right now. And it's all coming along.
Okay, so we're going to experiment with what we were referring to as the lightning round, which is go down the list of big technology areas and see if we have a quick take on it. So let's see how this pans out and if it becomes a regular feature. So IoT, we already covered. 5G, 6G, anybody has a take on? Okay, I guess my comment is that it's the spectrum of technologies for communications from Zigbee and LoRaWAN and Bluetooth and LTE and 5G and 6G and then all of that. So that spectrum is what comes to my mind.
The governments are gradually releasing spectrum that was reserved for other uses, for commercial use. And so we're still seeing some spectrum auctions, and there's a lot more bandwidth available in the spectrum than we are currently using.
Right.
So that's, I think, the good trend to follow is every time we open up new spectrum areas.
There's also challenges as you get faster because now you need line of sight. You can't have everything at the same time. If you're having a lot of devices, then you can't be that fast. If you want to be fast, then it needs line of sight. So those conditions being in place at the same time makes the promise less likely than everybody has everything at the same time.
I bought a Wi-Fi 7 router and put it in the bedroom, just above the bed. And if we're actually sitting in bed, I think I can get almost a gigabit off my phone. If I move to the other side of the room, it drops down again.
There you go.
The coverage is so local that, okay, that's where we're just sitting there browsing stuff. That's the main bandwidth. That's where we're sitting watching videos, all right?
Right.
But it seems like most of the house is running on some old crappy, 2.4 gigahertz slow thing, because that's what actually works.
Because that's what penetrates,
far enough, goes through the walls and things. Yep.
So HPC we covered with the top 500. AI we covered with the AI coding. Quantum, any comments on quantum? I'll chime in. A lot of discussions, a lot of news on roadmaps for quantum computing. Notably, IBM now promises that they would have a 200 logical qubit in a fault-tolerant way by 2029, in 4 years. So very ambitious, but also very exciting. So we root for them. Hopefully they can do it. Crypto, we already covered with crypto. Report from Steve. Cloud, what's going on in cloud? Adrian, you would track that.
I think, well, we can do this sort of the monthly update on how CoreWeave stock price is going. Their range now, I think they peaked at 180. They're currently sitting in the 160 range. They still seem to be cranking on. AWS still doesn't have any NVL72 racks on their price list. You have to buy it in the old style, 8 GPUs and an Intel chip architecture, air-cooled is really all they have. They may have stuff that they're selling directly to people, but on the public price list, that's what's there. And their AWS is sort of doubling down on Trainium, but it's an air-cooled thing. It's lower density. The networking is mostly Ethernet derived, so it's not got the same Ethernet bandwidth. And they've got their own cost model around it, but it's, unless you're doing a deal with them, it's probably more expensive than going to CoreWeave, just because AWS has got more enterprise-style premium pricing right now. So that's kind of where we are. The other thing I noticed, going back to discussions around carbon accounting, AWS released another update to their carbon accounting tool. They now have the location-based metrics, which are a welcome addition. And they now seem to be on a cadence where they're releasing stuff every few months, which is another huge step forward, because for a few years, there was no team delivering anything. There is now an engineering team, and they are doing reasonably regular releases of features that people have been asking for years. So from that point of view, I'm happy that AWS is that corner of AWS is getting its act together. I still think that Anthropic has a big deal with AWS. I'm not sure how much of Claude runs on Trainium or on Inferentia, or how much is running on NVIDIA stuff elsewhere. But Claude works. So if that's driving capacity at AWS, then that's good. I don't know.
It's
What the
definitely
real
a very
backend.
notable development, regardless, because it's
Yeah.
just the heft of the company kind of makes it notable.
Yeah.
Cybersecurity, pass, comments?
There's been a lot of issues, particularly in the UK recently. Some of the retailers of the cyber attacks and with different amounts of response. Marks and Spencer's and had its systems down for a long time. Their recruiting site was down. There were a whole bunch of things lasting for a really long time. A similar attack on another grocery called the Co-op was over much more quickly because they just were in a better state. So a lot of it comes down to you're going to get cyber attacked. The better prepared you are, you're still going to probably go down, but you're going to recover better. That seems to be what's happening right now, certainly in that area.
The other thing in cybersecurity is quantum computing and its potential threat to cryptography everywhere. The US and the UK and now Europe have basically come up with similar schedules in terms of requiring businesses and banks to catch up to that. Basically, like get started now, be done by 2030, and then be thoroughly done by like 2033. Those are roughly about the same timeframes for all of them. And Steve, I know you track that as it relates to Bitcoin and banking in general.
There was an announcement. I just saw something come across in the press today. Said Chinese cracked 22-bit RSA. Okay, but if you want to crack 44-bit RSA, it's 4.2 million times more difficult.
Right.
And we're at 256-bit, and elliptic curve is more difficult than RSA. So there's a long way to go.
I can crack 3 bits without any help. All right. We end with fusion. Anything new in fusion energy?
Fission, not fusion. You may have noticed that uranium has been in the news
This is true.
this
It is, yeah.
past week or so. So let's talk about fission rather than fusion, but not precisely in that context, although more generally about, global nuclear energy. Recent UN climate talks, there was a pledge to triple the amount of nuclear energy by 2050. And we're certainly seeing, a lot of momentum build and political momentum and actual, movement. The US is still number one, deployed nuclear power. France is still number two, but China and Asia are moving up quickly. And in fact, there's some new nations coming in with their first reactors. And this year, both Turkey and Bangladesh will put their first nuclear reactors into operation. And Egypt has one under construction, but it's a few years off before it would be commissioned. We're seeing a more advanced designs. These are called Generation 4 designs. And in particular, they're using different cooling techniques. The reactors that exist today are primarily water cooled, but some of these new techniques include salts, for example, fluorine-based salts and sodium, liquid sodium cooling, and other techniques. Kairos is an American company that's using a fluorine-based salt. TerraPower, another US-based company working on Gen 4 reactors with the liquid sodium coolant. The Chinese are looking at very high temperature gas cooling using helium in particular. DoD is going to be the first in the US to put a Gen 4 reactor into the field. It'll be a very small scale. It'll be a micro reactor and it'll be hosted at Idaho National Lab and should be in operation next year. There's a big move. Bitcoin had been the bogeyman for, gosh, is it using too much energy? And that's shifted the last 2 or 3 years clearly to AI. And how are we going to fuel all of the AI electrical input requirements? And people probably know that Microsoft and others have been making moves. And some of those moves involve nuclear power so that they can get more electricity into their large facilities. In particular, the 3 Mile Island one of them is going to be running again. It gets all of the commissioning approved.
Yeah, that was Microsoft. And then AWS has cited a new data center on a existing nuclear reactor, like a gigawatt scale reactor that was being underused locally. So they basically do a full offtake or whatever. And then the argument was whether the data center was behind the meter or not, whether they could count it as feeding directly or whether the production was effectively going to the grid and back, which is mostly just down to accounting
Yeah, in
rules.
fact,
Those are
Amazon is funding some SMRs, some small modular reactors.
They're all funding SMRs as well.
Yeah.
Yeah. The problem
Yeah.
is that it takes too long to build these things. The small ones, which are going to be quick to build, are not really in production yet. The big ones take a decade. So what's actually happening with AI is they're building gas plants, and there's an XAI data center running a bunch of really dirty gas generation that people are complaining about right now.
Right.
There's
Right.
a new development somewhere. I forget exactly what the story was.
There's
but
one in
Memphis?
Memphis
they
that
were building a whole lot of gas
Yeah.
stations, and the local people were kind of going, well, are you going to be on the, are they still going to be needed in a decade, and who's going to be paying for them then? So anyway, there's going to be a lot of, there's a lot of power going into data centers, but there's actually a lot of power going into space heating and transport as well over the next few years. So I think altogether, we're looking at the electrification of a lot of energy, and then can we produce enough clean energy to support that? I think it'll start to line up a bit better in a few years, but the sudden appearance of the AI workloads is causing issues. And then the other thing with the AI workloads for training in particular is all the GPUs can turn on very quickly, and that actually blows the local data center. The semi-analysis guys just posted a really long, detailed blog post about this, basically saying you need to have local batteries to act as a buffer between you and the grid. Otherwise, the GPUs will kill the local power station.
So this is our new roundup section, more so than lightning.
Much more stories got
Thunder, thunderstorm, not lightning. Yeah.
All right. So on that note, we can conclude this episode. Thank you all for being here. Thank you, Chris, Steve, Adrian.
Cheers.
Okay, thank you.
And thanks to our listeners. Till next time, take care.
That's it for this episode of the OrionX Download Podcast. Every episode is posted to orionx.net and shared on social media. Use the comments section or tweet us with any questions or proposed topics of discussion. If you like the show, rate, review, and share it. The OrionX Download Podcast is a production of OrionX. Thank you for listening.